Good day everyone, my name is Said from the Bridge Tutorial Center, and today we want to take a look at a subtopic called rotation of a plane mirror in physics. Let's start. Okay, so let's say we have our plane mirror like this. As you know that when you are talking about a plane mirror, the first thing is that you are going to have a glass. So assuming this is your glass, okay, this is your glass. If you want to turn a glass to a mirror, you have to coat it at one side. So let us coat it at one side. As you can see, the glass is a plain glass. So once we've coated it at one side, it has changed to a mirror. So this is now a plain mirror. So what's the next thing? What we want to talk about today specifically is about what will happen to the reflected ray when you rotate a plane mirror. So let's see. So the first thing you have your incident line, incident ray. But before you talk about your incident ray, whenever you draw a plane mirror, the first thing that you must draw is is your normal. So let us draw a normal. So these are normal, and your normal is always perpendicular to the surface. So you have your normal here. So this is the normal. I will put normal. Okay. So now let's say you have your incident ray coming like this. Don't forget that ray is just a path for light to travel. So we have our incident ray. So let's say we have incident ray. So this is our incident ray. This is the direction. So you can see that the incident ray has struck our plane mirror. So the first thing, let us indicate the angle between the incident ray and the normal. That angle is called angle of incidence, and it is being denoted by I. So I will call it I. So the next thing, once the incident ray has struck the plane mirror, the incident ray will be reflected. So let's see our reflected ray. So we have our reflected ray like this. Okay, so these are reflected ray, and don't forget about the direction. And the angle between the normal and the reflected ray is called angle of reflection, which is being denoted by small letter r. Okay, and these are reflected ray. So normally these are our plane mirror should be the incident ray, the normal, and the reflected ray. But what will now happen to this reflected ray when you rotate the plane mirror? Oh yeah, let us rotate it. So this is the initial position of the plane mirror. Let's say this is our initial position of the normal. Assuming you now rotate. If you rotate, we are going to have it like this. So you can see that your normal change and your plane mirror position also changes. So let's say you rotate it like this. Okay. Let's say you have something like this. Sorry about my line. So we have this is the first position P1 of the plane mirror. This is the second position P2 of the plane mirror. So let me because what we've drawn before is just a glass, let us change it to a plane mirror. This is now a plane mirror like this. So our angle, the angle of rotation, let us call it theta. So this is angle of rotation. So our plane mirror is being rotated by by theta. So what will now happen to the reflected ray? The first thing we have to note is that initially our plane mirror is like this, our normal is like this, but you've rotated the plane mirror like this, our normal will also be rotated like this. So let us draw the new normal. So these are new normal. These are new normal. So I will call this one number 1. Why this one will be number 2? Don't forget number 1 is just the normal for the initial position of the plane mirror, while the number 2 is just the normal for the new position of the plane mirror. And the angle between the number 1 and number 2 must also be theta. So if this is theta, okay, if this is theta, so let us take a look at our new angle of incidence. You know, this is the incident ray, this is the normal the new normal. And the angle of incidence is the angle between the incident ray and the normal. So since our normal has changed, our incident angle will also change. So we have from here to here. And you know, from here to here, which is here to here is I, here to here, or here to here is theta. So everything from here to here will now be I plus theta. That's our new incident angle of incidence. So let's say this is my I2. Let me call this one I1. This is I2. So I2 equals to I1 plus theta. I1 plus theta. So that's the first one. Now, what about this one? We have from here to here to be theta, and everything from here to here is r. What will be this small angle here? We can all see that this small angle will now be what to r, which is from here to here minus here, which is what to minus theta. So we have something like this. So what's the next thing? So since our angle of incidence has changed, our angle of reflection must also what to must also change. Okay? And what's the angle of reflection? We all know that angle of reflection is the angle between the normal and the what to and the reflected ray. But the first thing is that this is our reflected ray 1. What about our reflected ray 2? It will also change. Okay? So our reflected ray 2, we also, we are coming from here, it is rotating. So initially it is here, it will also rotate. Okay, so let's say this is the new reflected ray. New reflected ray. And our main concern in this subtopic is to find the angle between the initial reflected ray and the final reflected ray. So this is what we are looking for, which is x. This is what we are looking for, the angle between the initial reflected ray, which is reflected ray 1, and the reflected ray 2. Let us call it x. So how do you find your x? But before we find our x, what about our new angle of reflection? The angle of reflection is the angle between the normal, which is we are considering the new normal n2, and the new reflected ray. So it is from here to here. That will be our R2. Okay. Now let us find this x. How do we find this x? You can see that from here to here is R2. From here to here is R1 minus minus theta. And we are looking for this x, which is from here to here. So our x will now equals to what? Everything, which is R2 minus from here to here, which is R1 minus theta. So we have we have something like this. Minus, you introduce a bracket. So we are talking about R2, which is everything here, minus from here to here. Do you get it? So we have x equals to R2 minus R1 minus theta. So what next? So our R2, as we all know that according to the law of reflection, don't forget that the law of reflection states that the incident ray, the reflected ray, and the normal all lies on the same plane. That is the first law of reflection. The second law of reflection states that the angle of incidence must equal to the angle of reflection. That is our I2. Our I2 must equal to our R2. So, and we've known that our I2 is I1 plus theta. So we can assume that our R2 is also I1 plus theta. So let us take note of this. So our x we now equals to, what's our R2? Our R2 is now equals to I2. So we can say I2 minus R1 minus theta. So we have x equals to, what's our I2? We have I1 plus theta. So I1 plus theta, everything minus R1 minus minus theta. So we have x equals to, our angle of incidence must equal to angle of reflection. So if this one is I1, it must equal to R1. Okay? So we have I1 plus theta minus, I can change this one also to I1 minus theta like this. So you remove the bracket, we have x equals to I1 plus theta minus, what about this one when you open the bracket? I1 plus plus theta. So what will happen? We collect the like times, we have our x equals to I1 minus I1 plus theta. So what we have? I1, we cancel I1, we have I1 minus I1. So we cancel that, we have our x now equals to theta plus theta. So our x finally we equals to 2 theta. That's what we are trying to derive. So whenever a mirror is rotated through an angle theta, the reflected ray will rotate it through an angle to theta. Okay, so we are now done with with the proving of our subtopic, which is whenever a mirror is being rotated through an angle theta, specifically a plane mirror is being rotated through an angle theta, the reflected ray will rotate through an angle 2 theta. So now let's take a look at some examples. we have two different cases that can come out in both your JAMB and post-UTME. So let's take a look at the first example in the first case. So we have this question: if a ray incident on a plane mirror at an angle of 30 degrees, and the mirror is now rotated through an angle 20 degrees, find the first question, the new angle of incidence. The second question, the new angle of reflection. The third question, the angle through which the reflected ray is being rotated. Now, let's start from question 1. Okay, they said the new angle of incidence. From what we've just derived from here, our new angle of incidence, as you can see from there, is going to be I2, which equals to what to I1, which is from here to here, plus what to theta, which is the angle of rotation. So yeah, let us solve it. Okay, what we have here, the first thing in physics, don't forget you write out your parameters. What are the parameters? Okay, we have our angle. Incident, if a ray incident on a plane mirror at an angle of 30 degrees. So our angle of incidence, which is I1, our I1, let's start from there. I1 equals to 30 degrees. And the mirror is now rotated through an angle 20 degrees. Our angle of rotation, which is theta, equals to 20 degrees. So those are the parameters being given in the question. So our first question, which is question A, the new angle of incidence. What is the new angle of incidence? You can see I2 equals to I1 plus theta. So we have our I2 equals to I1 plus what? Plus theta. So I2, we now equals to I1, we have 30 plus what? Plus 20. So, and this will give us I2 equals to 50 degrees. Don't forget, this is our I2 equals to 50 degrees. So what about the second question? The new angle of reflection. So for the new angle of reflection, so we have our R2. So we can do it in different ways. But the simplest one is just that we all know that whenever you are talking about reflection from a plane mirror, our angle of incidence must equal to the angle of reflection. So our I2 must equal to R2. So our R2, which is unknown, R2 must equal to I2. Hence, our R2 must equal to what is our I2? 50 degrees. That's for the second question. What about the third question? Okay, the third question, the angle through which the reflected ray is being rotated. Sorry about this. A reflected ray is being rotated. So what's that? We all know that whenever a mirror rotates through an angle theta, the reflected ray rotates through an angle 2 theta. Don't forget it is 2 theta. So we are going to have our angle of rotation, which is the angle between R1 and R2. So, okay, reflected ray, ray. We now want to rotate. We rotate through what? Through 2 theta. So take note of that. The reflected ray we rotate through an angle 2 theta, which equals to, and you know our 2 theta, we now equals to, we have 2 multiplied by what's our theta, which is the angle of rotation, 20. So we have 20, which now equals to, finally, we have 40 degrees. That's our final answer. Thank you very much. Let us move to the second example. Let's start. So as you can see, this is our new the second example, which is the second case. And you can see the question: the reflection of a narrow beam of light, which incident normally on a plane mirror, fall on a metal rod parallel to the mirror at a distance 70 centimeters from it. So that's the first thing. So let us draw that sentence. Okay, the reflection of a narrow beam of light, which incident normally on a plane mirror. So the first thing, let us draw our plane mirror. So assuming this is our plane mirror. Okay, so you have your plane mirror, you quote it. So this is the plane mirror now. So it now said the reflection of a narrow beam of light, which incident normally on the plane mirror. So that is the thing incident, the light incident, the beam incident normally onto the onto the plane mirror. So let's say this is the these are normal, which is the first thing you draw when you are talking about a plane water, a plane mirror, this is the normal. But they said this incident ray also incident normally, that is strike normally onto the plane mirror. So that is our incident ray will also be coming like this. This is the incident ray normally. So we can also put our incident ray here, IR. Okay. So what's now the next thing? What's the angle between the incident ray and the normal? You can see both of them are parallel. So that means the angle of incidence is 0. You know, when something are parallel, the angle of incidence must be what? Must be 0. Okay. So what's the next thing? If our angle of incidence is 0, what's our angle of reflection? Don't forget, according to the law of reflection, the angle of incidence equals to the angle of reflection. So we are going to have our reflected ray. So once the incident ray strikes it like this, our reflected ray is also coming back like that at an angle of reflection 0 to 0 degree. Don't forget. So this will be our reflected ray. Okay, reflected ray 1. So what now happened? Okay, he now said the reflection of a narrow beam of light, which is normally on the plane mirror, fall on a meter rule. Now this reflected ray, as it is coming upward, it falls on something which is the meter rule, and the meter rule is parallel to the mirror. So let us draw the meter rule. So we have like this. So let's say this is our meter rule. So the reflected ray will now falls on it. So and they said the distance between the meter rule. This is the meter let me use this meter rule. This is our plane mirror. They said the distance between them. So what's the distance between them? 70 degrees. So from here downward like this is 70 degrees. Okay, so what's the next thing? By what? Okay, if the mirror is rotated through an angle 10 degrees, the mirror is then rotated through an angle 10 degrees, by what distance is the reflected ray being displaced along the meter rule? That's our question. So don't forget, they rotate the mirror through an angle 10 degrees. So our angle of rotation is equal to 10 degrees. Don't forget that whenever a mirror is being rotated through an angle theta, the reflected ray will rotate through an angle 2 theta. So rotation of the reflected ray, rotation of reflected ray is equals to 2 theta, which is equivalent to 2 multiplied by 10, giving us 20 degrees. So okay, so our reflected ray, instead of coming up like this, it will rotate through an angle 20 degrees now. Okay, so we have the mirror like this. Okay, initially this is our this is our reflected ray. Okay, to now rotate the angle through an angle 10 degrees. So reflected ray will rotate through an angle 20 degrees. Let me see like this, as you can see. So this will be our new reflected ray. Okay, it won't be parallel again. Okay, so these are new reflected ray, and the angle through which it will rotate is 20 degrees. If this one is RR1, this one, the new reflected ray here, will now be equals to RR2. And okay, so they now say by what distance is the reflected ray being displaced along the meter rule? That is, this is our initial reflected ray, this is our final reflected ray. So by what distance are they being being displaced? So let us call it x. So if this one is x, let us solve it. Using our normal trigonometry, you can see we have our right angle. You can bring out the triangle to the triangle. You can see that the triangle, I just use this place. We have our triangle like this. Sorry about the freehand sketching. So we have our x. We have this one to be what? To be 20 degrees. Okay, we have this one to be reflected ray 1, RR1. We have this one to be reflected ray 2, which is RR2. Okay, and the distance from here to here is 70 degrees. So what do we use? We have our right angle. So as you can see here, we have our opposite and adjacent. So we use tan. So we have our tan theta equals to opposite of our adjacent. Okay, so we have our tan 20 degree. Tan 20 degree, we now equal what? We now equals to what? Okay, so we have our tan what to tan 20 degree. We now equals to what's our opposite? We have our x divided by what's our adjacent? We have 70 centimeter. So finally we have our x equals to 70 tan what to tan 20 degree. Then you press what? You press this one. So use your calculator. 70 tan 20 degree. So what do we have? We have 25.4779. So our x equals to 25.4779. Approximately x equals to 25. You know, x approximately is equal to 25.5 centimeter. So that is our final answer. So as you can see, these are the two major type of question you can see when they are talking about the rotation of a plane mirror. The first case, which is a little bit simpler, and this one which may seem a little bit complicated, but once you've practiced it and understand it very well, it is very simple. Join us at the Bridge Tutorial Center. Thank you, everyone.